The difference in potential between point C and D is VCD. That is, VC minus VD is equal to 2 volt. Since VC is equal to 0 volt, then VD is equal to 0 minus 2 is equal to minus 2 volts. D should have a lower potential of minus 2 volts. Similarly, since the cell has 8 volt EMF, the difference in potential between point D and A is VAD, with VA at a higher potential. VA minus VD is equal to 8 volt. VA minus 2 is equal to 8 volt. Since VA plus 2 is equal to 8 volts, VA is equal to 6 volts. Charge gains potential as it passes through the cells because chemical energy is converted to electric potential energy. Must point A still have a potential of 8 volts and D a potential of 0 volt so that the EMF of the cells remains at 8 volts? Well, point A can have a potential of 6 volts and D a potential of minus 2 volts if point C is Earth. Despite the change in the potentials at various points, there is no change in the potential differences and EMF of the circuit. Just like gravitational potential, electric potential may be zero potential at any point as desired. Just like in this case, point C is made to have 0 volt. Is there another name for potential difference? Voltage. What are the similarities and differences between potential difference and EMF? Well, both potential difference and EMF use the same unit, volt, and both relate to an exchange of electric potential energy with other forms of energies. However, we use the term EMF to refer to terminals where electric potential energy is produced from other forms of energies. For example, for a battery where electric potential energy is converted from chemical energy. For potential difference, we use the term to refer to terminals where electric potential energy is converted to other forms of energies. For example, for a bulb, where electric potential energy is converted to light energy and heat energy. Potential at a point is defined as the work done required by an external body per unit charge to move the charge from infinity to that point. Since you have learned the definition of potential, which when stated in general is the work done required by an external body per unit charge to move the charge from infinity to that point, why don't you suggest a definition for potential difference? Give it a try. The value of the potential 8 volts at A implies 8 joules of work done by an external body is required per unit charge to move the charge from infinity to that point. The value of the potential 2 volts at B implies 2 joules of work done by an external body is required per unit charge to move the charge from infinity to that point. What if you don't move the charge from infinity, but from B to A instead? How much work is done? Give it a try. If charge is moved from B to A, the extra work required by an external body per unit charge will be 8 joules minus 2 joules, which is equal to 6 joules. Hence, 6 joules is required to move a unit charge from B to A. You need to increase your work. 6 joules per unit charge is 6 joules per coulomb, which is 6 volts. Hence, potential difference between point A and point B can be defined as the work done per unit charge to move the charge between the 2 points. What if you move the charge from A to B instead? How much work is done? Is this going to be the same as from B to A? If charge is moved from A to B, there is less work required by an external body per unit charge. It's going to be 2 joules minus 8 joules, which is equal to minus 6 joules. Where has the work gone to? From previous discussion, the work was dissipated as heat energy, which is a resistor between point A and B. Hence, a more complete definition of potential difference between point A and point B can be the work done per unit charge to move the charge between 2 points. In the case of potential difference, the electric potential energy of the charge is dissipated as other forms of energies such as heat or light energy as the charge moves between the 2 points. If it is a case of a battery, we refer to the difference in potential as EMF, electromotive force. A different term is required here to distinguish a difference in the process of transfer of energy. EMF is the amount of energy per unit charge converted from other forms of energy to electric potential energy as the charge passes through the terminals. The other forms of energy can be, for example, chemical energy or kinetic energy. As a final check of understanding, do try to answer these 2 questions. First question: what is the electric potential energy lost per unit charge after it has gone from A to D? Second question: how much electric potential energy is given to the charge when it goes from D to A? Well, it is 8 joules per coulomb for both questions. Do review the lesson if you still have some doubts. In summary, potential at a point is defined as the work done required by an external body per unit charge to move the charge from infinity to that point. Potential difference is the work done per unit charge to move the charge between 2 points. In the case of potential difference, the electric potential energy of the charge is dissipated as other forms of energies, such as heat or light energy, as the charge moves between the 2 points. EMF is the amount of energy per unit charge converted from other forms of energy to electric potential energy as a charge passes through the terminals. The other forms of energy can be, for example, chemical energy or kinetic energy. That will be all for this time. I hope you have a good understanding of potential difference and EMF. Thank you for your patience. Adios.